Hello, in this video we're going to discuss the resistance heating. Let's check it. When an electric current passes through a resistor, then there will be a power supplied to this resistor. Recall that the power is equal to the current multiplied by the potential difference. This power supplied to the resistor heats it up, and when the resistor heats up, it transforms this heat to the surroundings, so the energy supplied to it is dissipated to the surroundings. So how is this power affected by the resistance of this resistor? Let's check it through the equations. We have defined that the power supplied to the resistor is equal to the current multiplied by the potential difference. And we know from Ohm's law that the potential difference V across the resistor is equal to the current multiplied by the resistance, I multiplied by R. Let's replace the potential difference V into the equation of the power. Then the power supplied to the resistor, P in watts, is equal to the current multiplied by the current multiplied by the resistance. So we have replaced V by I multiplied by R. And I multiplied by I gives an I squared, so the equation of the power reduces to current squared multiplied by the resistance. Hence, the power supplied to the resistor in watts is equal to the current squared in amperes multiplied by the resistance R in ohms. This equation shows that the power supplied to a resistor is proportional to the square of the current. So, for example, if the current is doubled, let's replace I by 2I1, then the new power, P1, is equal to 2I all squared multiplied by the resistance. So P1 is equal to 4I squared multiplied by the resistance. We can replace I squared multiplied by R by the initial power P. Therefore, the new power P1 is equal to 4 multiplied by the old power P. So, if the current is doubled, the power becomes 4 times greater. That's all. Thanks for watching.